So, hello and welcome to the DV Digest. My name is Brody, and this is your monthly digest of insight from design verification leaders. Now, today's guest is Kaleb Barrett. Kaleb is currently an FPGA verification engineer at Hudson River Trading, which is a low latency trading firm. But more relevantly for this conversation, at least, he's the lead contributor at cocotb. During the podcast, we talk about a few different things. We talk about the new 2.0 update and what you might need to change on your test benches. But we also talk about his vision more widely and what might be coming in a prospective 3.0 and 4.0 update. I think it's a super insightful conversation, and I really hope you enjoy. So, Kaleb, I really appreciate you coming on the podcast. If people don't know what cocotb is already, could you do us a favor and let us know what it is?
Sure. So to put it very simply, cocotb is a library that enables you to write your test benches in Python. And you can tell kind of based on the name a little bit more details about that. So cocotb is the coroutine co-simulation test bench. And so it's just a test bench language. We're not supporting Python for RTL development or anything like that. It's co-simulation, so we're using VPI, VHPI, FLI, DPI. There's kind of like standardized interfaces that simulators provide and running outside of, but next to the simulator. And then the coroutine thing. So if you know anything about those simulation interfaces, they're all based on callbacks, and that can get very tedious very quickly with large code bases. So what cocotb provides is coroutine scheduler and triggers, things like that, to kind of bridge those callbacks into something you can use in Python more easily. Async await syntax is what Python 3 has, and makes it very natural. You can write more sequential looking code that way. So that's kind of what it all is together.
Oh, nice one. All right. I mean, we spoke to Andy last week, Andy Bond, and he was telling us about all the benefits of using Python. So if you guys haven't seen it already, go check it out. We won't go too deep into that right now. But if you could tell us a bit more about a new update that's coming out. I know that you guys are close to a beta or something like that for 2.0. What's involved in the new update, and what can engineers benefit from by using it?
Sure. So I got the last couple PRs up for the 2.0 update earlier this week. So the beta should be coming in the next couple weeks or so. So please test that out if you haven't already. And kind of the rationale for why we ended up doing that was when Flossie inherited the code from the original authors back in 2018 or so like that, there were some things that needed to get cleaned up. Probably the biggest one was the fact that there was really no attention to like what was private versus what was public API. And throughout the 1.0 release, every minor one kind of like broke some small things in some ways, and that's not great. People want to be able to depend upon their API. So 2.0 is kind of like the big cleanup so that we can make better guarantees going forward about the stability of the API. And it also allows us to like remove some other code that kind of prevented us from being able to make improvements. So, yeah.
Okay, cool. So what will engineers need to change in their test benches? What is there anything that they will need to change, or what's the situation there? What does it mean for engineers actually kind of using cocotb at the moment?
Sure. So there's going to be a bunch of mostly small changes. Like you might need to change an import here or there, or you might need to update to newer interfaces that have been deprecated for a while that are finally being removed. So like if you're still using cocotb.fork, that was removed. Sorry. Uh, but what else is there? The other big one is going to be the fact that we changed the modeling types. So we used to be able to get binary values back from the logic signals from the DUT. And now there we have a new set of modeling types that is, and they avoid some of the issues that are in the binary value, and it's kind of a hard break. It should be mostly compatible, but you might find some small times where it's not compatible. Certainly if you're constructing them, it's gone, so sorry. Um, And the other big one was the change to the scheduler. So we removed cocotb.fork, I mentioned that. And also we removed support for old Python 2 style coroutines, which was like the decorator on the yield syntax. And both of those things allowed us to make several improvements to the schedulers in 2.0. There's even going to be more in 2.1. And just rough estimate based on some of my testing that has allowed us to just eliminate an entire class of bugs and increase the performance of the scheduler like 5 to 10x. So yeah, pretty nice improvements there. Yeah, those are the two major things people need to worry about.
Yeah. Did I read somewhere that you're doing something for running regression tests, or am I wrong there entirely?
So there was a test success exception that people would throw to kind of end the test early. And that was replaced with cocotb.passSoon, which is a function instead of like an exception that you throw. And that's like it's another small difference. Like I said, there's like probably a dozen of those like kind of small differences, and that is mostly to kind of like mirror where we're going in the future because we want to support PyTest functions for doing that, like PyTest.skip, PyTest.xfail. They don't have anything like that for past tests, so that's why we had to do it ourselves. And it really is just there to prevent people from doing not great things with test success. I've seen so many people try to catch test success, but that's just, it's not how it works. As soon as it hits the scheduler, it goes through some like special path. You can't catch it in the general case. So it's refactoring just to like prevent people from shooting themselves in the foot.
Okay. All right. Um, so if I've got this right, then you're essentially laying the groundwork for future improvements.
Mhm.
So what's on the roadmap? What are you planning?
So near future, you can kind of go back and look at my talk with at OrConf last year, where I went over some of the 2.0 features. We
Yeah.
didn't get all of them in, like the big one at the end, the task manager didn't make it in, so that's going to be in 2.1. And that will, again, it's designed to allow people to not shoot themselves in the foot as much with some of the concurrency. And it's something that's been taken from, System Verilog's fork join and like the other Python coroutine uh, systems have it something similar. Like async is task group and Trio has the nursery. So it's kind of like all based off of that. That's going to come in hopefully the next release, minor release. We're going to be expanding the set of modeling types. Right now it's just logic array, but we're hoping to get in something like pack structure support for Verilog. Maybe additional support for things like signed, unsigned, fixed points, floating points, like mostly based off of like VHDL's data types, because they're done pretty well, in my
Yeah.
opinion. And just more cleanup, more performance improvements, and maybe a story or two about like improving DPI compatibility.
Okay. All right. What's your sort of vision for cocotb? Where do you want to take it?
cocotb at the past was originally intended to be a one size fits all monolith. This is how you do it, kind of like System Verilog UVM. And we're trying to kind of move away from that a little bit, or at least my efforts are. We still want people to be able to just pick up and use it, but we also want it to make it extensible enough so people can experiment. So, we have multiple methodologies that sit on top of cocotb in existence. There's multiple UVM implementations. Last episode, we talked about AVL. There's also Ferostero, and pretty much everywhere I've worked has one or multiple internal methodologies that they build off of. And so we want to be able to reorient cocotb in a way that better supports what those people want to do. So cocotb more as like a library or a set of tools instead of like the way you do X, Y, or Z. Less prescriptive, more reusable.
Okay. And so how do you see that kind of planning out? What changes do you need to make, and what do you have in mind?
So you'll see if you ever work in like a company that uses cocotb, like they've started to replace those pieces bit by bit as they need them. Like the first one to go usually is like people don't use the make files. People don't use the Python runner. They have existing build system. They have existing regression system, and they just want to tie their stuff into cocotbs and integrate that. And that's partially done, and we want to like improve that a little bit by replacing the regression manager that sits inside cocotb, and that should be able to provide additional functionality, like even for people who don't have that. Like we want to be able to support PyTest as a way to do test discovery, use fixtures for doing builds, and what else is there? Like we can reuse all of the existing functionality in PyTest that way. So it's not just people inside of companies, but even other cocotb like FOSS frameworks can take advantage of existing functionality in that way.
What's going to justify 3.0? What's 3.0 going to look like in your eyes?
So, a couple things. We tried to break as little as possible with 2.0, and so a lot of things that we would like to remove were simply just deprecated. And eventually those need to be cleaned up. It's an API break. That's the 3.0. But I think the big 3.0 is just moving to kind of a new era of doing things. So cocotb right now, like the GPI it only works for cocotb. The PyGPI only works for cocotb. The regression manager only works for cocotb. Eventually, all these things will be cleaned up in such a way that they can be individually reusable. And I think 3.0 is like, here's a smorgasbord of tools that we've built for verification. cocotb will still exist as this like one way of doing things, but here is like the new stable API, like all the cool stuff that cocotb is made of that you can just kind of use however you want for those new verification methodologies, for hardware testing, for you name it.
Most of the simulators now have like a hook essentially for cocotb. Can you see a path to a like a single debug cockpit? So where you can do your kind of Python debugger and have your waveform viewer in the same, window essentially.
So I guess it depends exactly what you mean there. There are other examples of multi-language debuggers out there, like GCC can debug both C and Python at the same time. So you can definitely have like Python debugger and a waveform viewer operating at the same time right now. But if you're talking about like doing steps inside of your commercial simulator, like they do, like the take a step, play, whatever, there's not really an existing API for that. Like the VPI, VHPI, all that don't really have that functionality built in. And so we'd have to petition the simulator companies to build those APIs. They'd obviously have tons of disagreement because each of their debuggers is probably wildly different. Or we'd have to like pressure them to be like, hey, you need to add multi-language support to your debugger, which they may or may not be happy about providing. That's probably like the most reasonable way forward, is to get them to do what's necessary to support Python debugging. So there's not much we can do, unfortunately.
Yeah. Okay. Um, why are you on this project? Why are you the one that's running this? Is it because you enjoy it? You like building things, or what's the reason that you've got involved?
So I got involved, like I've been using cocotb almost every day since I started my career. And yeah, I started at Raytheon, and that was the only thing we did. Our group was by cocotb only. And I used it every day. That was back in 2018. And it was kind of rough. Like I kept on running into bugs, or like, oh, that's not very good. That could be better. And it just, I don't know, something inside me is like, I can make this better. It's open source, so I have the ability to just go in and fix it if I need to. And just kind of got caught up in it. And it's taken me a lot of places, so continue to enjoy working on it. I do have another project that I've started up recently because there isn't like a ton of development or maintenance effort in the main cocotb repo. And we're trying to be as stable as possible with the new API. New features are probably going to be developed, I mean, as long as I'm the one developing them, in another project that I just started up called Coco Next. And it's just going to be a staging area for new features that are going to, they might break randomly from time to time. And that needs to be okay until we are happy with it. And then we can kind of just wholesale move it into CocoTB at that point. And we can be sure that it's well tested, has some provenance, it's not going to change. We're happy with it. I already have like the first release out that has like two little things in it, like a mailbox type and like a new notify trigger. It took me, all of 10 minutes to code up a piece, but I've seen people do them over and over again and fail to do them correctly. So it's kind of like where we're going with new features in CocoTB. We don't want to take on too much new scope, but the scope that we do take on, it needs to be something that people do all the time, and it's not terribly contentious. Like we've seen people do the modeling types over and over again, and sometimes they're great, sometimes they're not. And so that's kind of why I wanted to move in that direction with 2.0. But just trying to stay away from like being overly prescriptive. So uh, don't want to add any methodology type stuff to it.
Yeah. Okay. All right. That makes sense. Um, do you see this being a wholesale change in the way that verification engineers do verification, so moving entirely away from UVM system Verilog in the long run, or do you see this still as something that's a somewhat cheaper, easier alternative than having, all the boilerplate of UVM, etc.? Do you see this moving into a mainstream methodology and language?
Oh, absolutely. I mean, let's go way to put this. There are a lot of advantages for with Python over System Verilog, and I think Andy did a great job at detailing a lot of those last time. The one thing I think that he missed was the fact that Python, the entire ecosystem of libraries available to it, cocotb, all that stuff, is free and open source. So if you have a problem, you don't have to go beg a company to fix it for you. And depending on how big the problem is and how many licenses you buy, you may or may not get that fix 3 or 6 months from now, maybe. And instead, you can kind of just like immediately unblock yourself by just forking it, fixing it, and using it. Maybe contributing it back if it's just like a simple bug fix or something like that. And that style of development always wins. Who won the Unix wars? Was it Sun? Was it HP? No, it was Linux and GNU. And that's kind of how we plan on eventually winning in the end, is by embracing open source.
Yeah. Okay. Why hasn't it happened so far? Because the there's obviously a cost in changing. There's obviously a skills gap, I imagine. There's a lot more verification engineers that know System Verilog than I imagine know the level of Python that's needed for CocoTB. But why hasn't it happened in your eyes so far? Why isn't everyone using Python already?
So I think a lot of that is there's a huge ecosystem of existing code for verification and System Verilog UVM. Companies provide VIP that you can buy. Like even at a lot of these verification houses, like they have like something like VIP for all their internal interfaces set up already. And to say, oh hey, abandon all that and move to this other thing is it's a large effort. And maybe if there was like a little bit more of the VIP available for CocoTB, that could help. And I think Andy's point there of there being like a consistent framework to build off of would be very nice. So I'd like to see like one of those methodologies, UVM, AVL, or like any of those, like start to really succeed, because that's going to really propel it into popularity, I think. Because while there are a lot of people who currently know System Verilog, uh, if you just take random people who come out of college, their System Verilog's kind of so-so. but they tend to all know Python pretty well.
Well, Caleb, I think that's all the questions that I have for you. Super interesting. You're obviously passionate about this. Um, this is all open source. I love that. I love that you're driving forward something that you think is a positive change for verification engineers. And I really appreciate you coming on the podcast. So thank you very much.
Of course, and thank you for having me.
No worries at all. See you soon, Caleb.
All right, see you around.